second day of our standard form lesson. Today we're going to talk about how to write equations in standard form. So when we're given an equation in slope-intercept form, we're going to convert that equation to standard form. In order to do that, first of all, we need all of our variables on the left, because remember, standard form is ax plus by equals c. So our x and y are both on the left when we're in standard form. So that's the first step, is just get them all over to the left. And then we don't want to have any fractions in standard form. Standard form should always be fraction-free. So we might need to multiply to get rid of fractions. We also need to make sure that the first, that this letter a, that the coefficient in front of x is positive. So we may have to multiply by -1 to make that positive. So let's take a look at how that works with the example that we have up here. I'm just going to rewrite it so we can work down from it. Okay, so step 1 tells me I'm going to move variables to the left. So to move -3/7 x to the left, I'm going to add it to both sides. That will get rid of it on the right side and make it appear over here on the left side. So on the left side now I have 3/7 x plus y equals 5. Now I need to get rid of any fractions. So I don't want to have a 3/7 here. So I need to multiply by 7, which will get rid of the 7 in the denominator. Now you can't just randomly multiply one thing by 7 and not multiply anything else. You have to do it to all of the terms of the equation. So I'm going to multiply this by 7, I'm going to multiply the y by 7, and I'm going to multiply the 5 by 7. So here the 7s would cross off, it would cancel, and I'd be left with 3x plus 7y equals 35. Any questions about what I just did? The next two examples say you try. We're actually going to do the first one together, and then you'll try the second one. So everybody good to go on from this slide? Okay. All right, so let's look at the first one together. We have y equals 2x minus 6. Step 1 is move all the variables to the left. So I need to get rid of the 2x on this side. So I'm going to subtract it from both sides. So on the left side, I have -2x plus y equals -6. Now I need to multiply to get rid of fractions or a negative number in front of x. I don't have any fractions, so I don't have to deal with fractions this time, but I do have a negative number. So I'm going to multiply everything by -1. That will change the sign of all of my terms. And I get positive 2x minus y equals positive 6. Okay, go ahead and try the next one. There are also a few additional examples on the next page, which you are welcome to work ahead and try if you want to, but we will be going over those mostly together. Okay, let's take a look at this. I've seen a lot of you, most of you are doing pretty well with it. Question came up when we move this variable to the left side. Let's just do that, and the question is after that. We end up with -1/2 x plus y equals 4. You have two problems here. You have a negative number and a fraction. You can get rid of them all at one time. Some of you were either getting rid of the negative or getting rid of the fraction, and then you had to have a whole nother step. If you multiply by a -2, you will not have a negative number and you will not have a fraction. So you can multiply by -2, and then the 2's cross out, it's no longer negative, then we have x minus 2y equals -8. Okay, any questions about that I didn't catch as I was walking around? Okay, let's look at the additional examples. The next example is unique in that it has two fractions. Actually, I'm jumping ahead of myself. Let's move all the variables to the left. So I'm going to subtract 3/4 x from both sides. I end up with negative 3/4 x plus y equals negative 1/8. Now we don't want to have any fractions at all in standard form, so we want to get rid of the fraction on the right as well as the fraction on the left. What one number could we multiply by that would get rid of both fractions? Paul? 8. We could multiply by 8. Good. Because that would get rid of the 4 in the denominator, because 4 goes into 8 twice, so we have a 1 down here. Since we also have a negative in front of this, let's multiply by negative 8. Times negative 8. Okay, so I'm just going to make this negative 8 over 1. So when I'm simplifying before I multiply, 4 goes into itself once, and it goes into 8 twice. So now I just have a 1 in the denominator, so my fraction is gone. 2 times 3 is 6, so I have 6x minus 8y equals positive 1. This is similar to what we did when we had equations with fractions and we just wanted to get rid of the fractions. We multiplied by a common denominator, and that's what we're doing here as well. Yes?
I did the two-step. I did times -4, and I had 2 later. Is that okay?
That's fine. So Athena is saying she first multiplied by -4, and then once she did that, she saw, oops, it didn't get rid of this fraction over here. So then she went through and multiplied by 2 to get rid of what was left there, and that's fine. If you don't get rid of it all at once, you can do it in 2 steps. It just takes longer. Any other questions or comments about that one? Okay, let's look at the last one. The last one just has more that we have to do before we can apply the rules. So what would I do first to get this equation towards standard form? Lacey? Distribute. So y minus 2 equals negative 1/3 x, and 1/3 of 6 is 2, minus 2. Now I need to move my variables to the left. I also have a constant that I need to move to the right. So I'm going to start by moving this constant. So I'm going to do plus 2, plus 2. So I get y equals negative 1/3 x plus 0. Negative 2 plus 2 is 0. Move that 0 there for a second. Now I'm going to add 1/3 x to both sides. And now I have 1/3 x plus y equals 0. So I really didn't need to write the 0 here in this step, but I did need to write it here because you can't just have nothing on the side. You have to say 0. Okay, now I need to get rid of the 1/3. So what would I multiply by? Gretchen? 3. So I'm going to multiply everything by 3. And I get x plus 3y equals 0. Okay, questions? Okay.